Good morning to Anand. On behalf of EEE Department, SCAT College of Engineering and Technology, I welcome you all for today's webinar. Before we start, I would like to present a brief note about our college. Our college is 20 years young. 16 batches of students have successfully graduated so far. We are offering 5 undergraduate courses: Bachelor of Engineering in Civil, Computer Science, Electronic and Communication, Electrical and Electronic, and Mechanical Engineering. We are offering 3 PG courses: Master of Engineering in Computer Science, Applied Electronics, and Power Electronic Drives, and 1 Master degree in Business Administration. We have well-equipped digital library with 42,456 volume of books, 106 international journals, 2,500 online journals, 1,500 ebooks. We are having high-profile faculty community. Currently, we are having 60 doctorate faculty and 13 faculties are doing doctorates. We are carrying 30 plus funded projects under state and central government scheme like ASTD, UGC, DRDO, and DST, etc. We specially designed 9 applied labs for the student to impart latest technology, and 34 MOUs have signed with various companies. In last academic year, we have conducted 30 plus on-campus drive, 300 plus students placed, and 400 plus students getting offered. Knowledge is power. Knowledge only drives the man to lead a successful life. In this context, we are organizing today webinar on fire identification in buildings. Now, I would like to introduce our today webinar resource person, Mr. Engineer Er.Dossan, High Kennedy, Senior Electrical Engineer, ASTAD, Qatar, and second resource person, Engineer Anand Pillai, Commissioning Manager, ASTAD, Qatar. Before going to the section, I would like to address few instructions to the participants. If you have any question during the presentation, feel free to type in the chat box. We will bring them up at the end of the presentation during question and answer section. Feedback link will be posted at the end of the section. In chat box, you can view this webinar at any time in the YouTube link. Without any further delay, I invite Dosan Hai Kannadi to deliver the presentation. Please, sir.
Good morning all, and thanks Firminus for an opportunity to share my knowledge with the team, and thanks for the participants. Hope everyone is home and safe. The situation is not really good enough for us to meet in person. But however, thanks for the platform. Thanks for the internet connections, the power provisions in India and all around. And I'm here to share knowledge, what I have learned in this 15 years from my experience with all of you. The system is about, the presentation is about fire alarm system. Fire alarm system, now I'll start with what is fire alarm system. And my colleague, Mr. Dev, will explain what is fire protection system. So now the requirements of fire alarm system we'll start with. So what is the requirement of fire alarm system in a building and why we need this? So the reasons is fire alarm system is to detect that there is a fire in the condition, fire in the building, and to warn the occupants to avoid any casualties at any condition, any situation. simple as it is. Like analog addressable system, you go to every device individually and you address the systems. Okay. And digital addressable system is you can do it by software, by you can do all these devices from a centralized location. That is why it is called a digital addressable system. Now, going to the conventional or non-addressable system, as it is said, the system is non-addressable. You are not going to address the systems. So you will just have to label the devices one by one. So you will just label it. So you don't have a centralized system to monitor it. So the next one, what we are going to see further is standards to design. We have systems to install. On what basis are we going to install the fire alarm system and its relevant accessories? Now, we should understand the type of building, what it is. We cannot design a building based for a hotel building. We cannot design it as a hospital. A hospital cannot be designed as a ஸ்லைட்ஸ் விசிபிள் இல்லையா? நான் ஸ்லைட்ஸை அந்த ஸ்க்ரீனில் தான் பார்த்து சொல்லிட்டு இருக்கேன்ப்பா. இப்போ just give me a minute. Go here. Dossan is presenting. Resume to presenting. Share now. Is it coming?
Rufus?
Rufus mute இருக்காரு.
Rufus, slide present இருக்கா?
மைக்ரோஃபோன்ல தான் பேசிட்டு இருக்கேன்ப்பா. பட் இதுல ஆமா இட்ஸ் பிரசன்டிங்னு வருது. இப்போ கேக்குதா? லவுட் அண்ட் கிளியரா? ஹலோ, இப்போ கேக்குதா?
கேக்குது.
இது பெட்டரா?
இது ஓகே.
Resume presenting. Share now. ஸ்க்ரீன் வர மாட்டேங்குதுப்பா. presentation ஷேர் ஆக மாட்டேங்குது. Stop screen sharing. I'll try to present now and present your entire screen. Click பண்ணு. Okay, I think now you will get it. Hello. இப்போ வருதா?
Hello.
You are presenting to everyone.
Rufus, present.
Presentation வருது, slide தெரியலையா? You are presenting to everyone. The design has to be considered. Now, what are the components of? We'll see the components. Whatever is involved in a fire alarm system. So, what all is involved in a fire alarm system is we will have local alarms, we'll have indicator boards, and we will have reference fire alarm systems. So, what is local alarms is the notification devices installed around the building, which gives intimation to the occupancies, that is the people around them, to
vacate the building. So this is a local alarms. So indicator boards. So what is the indicator boards is it can be the main control panel or any sub panel or even a mimic panel. So which will show you where there is a fire occurred or where there is a fire condition occurred. Okay. So the reference for the alarm systems is a notification which can be given in zone separations. Like if you have a building of 20 floors, you will have a notice a fire in one of the area, but you will not be knowing it specifically. So in each floor or like in separation of 3 or 4 floors, you will have indication boards where you can see the fire alarm exact zone where there's a fire. So that is how it is. Now we'll see the input type of input devices now, and I'll explain you one by one how it works. Now this is the first what we are going to see is the initiation devices. So the initiation devices is like the first device what we are going to see here is a pull station or a manual brake glass. So what is this? Is we would have seen this in shopping malls wherever it will be a red color box which we can pull it so that it is a direct fire alarm and people will evacuate the building. So interface modules. So there are two types of modules, which is one is a control and a monitor module. So control is like we can give a signal so that the equipments are controlled. Monitor is that we monitor that the equipment is functioning, strobes, sounders, bells, and speakers. Okay. Now we'll see how a smoke detector looks like. So this is how a smoke detector looks like. The white color thing. This is a smoke detector looks like, and this is how the manual brake glass or a pull box looks like. So if you have if you have notified a fire condition, then full screen. So if you have a fire condition not notified, then you can pull this and go. So that is how it works. Now, on what basis these devices functions is going to be notified in here. So based on the time element. So you cannot have a smoke being persistent for a continuous time. So we should have a smoke detector installed in even distances and to monitor the fire such that the fire has been notified on a timely moment. So because there is no point in having a detector being installed, but the time sequential time is not provided. That is how it is. So the type of alarms we are notifying here is type A is manual alarm, type B is automatic alarm. So manual alarm is something which is initiated manually. So that is where the brake glass comes into act. So you pull it by yourself, you are notifying the control panel that is a fire, so it's called manual alarm. Type B is an automatic alarm which is initiated automatically by the smoke detector itself. Okay, and this is how the activation happens. So again, this is I'm trying to explain you more about the type of detectors and how it works. Okay, so there are three broad classification of these detectors again. So it is like heat, smoke, and flame. So from the words we can understand. So what is a heat detector? It will identify the heat. If there is a increase in the heat in a particular area, it will sense. So smoke is again for smoke. So flame is for flame detectors. Like when there's a flame, it will identify that the flame. So obviously that will be difference in type of flames. So it will identify the type of flames. So fire detectors are used in variety of fire prevention and suppression systems. Okay, so it's like just a brief of how it works and where it works. So now heat detectors, how a heat detector works is what it mentioned here. So there are two types of heat detectors again. So the heat detectors are either being called as a fixed temperature heat detector or a rate of rise heat detector. So what is a fixed temperature or what is the rate of rise? We are going to see here again. So fixed is like, say your room is supposed to be maintained 40 degrees Celsius. So the detector will identify and it will notify the control room. And what is the rate of rise? Rate of rise is like it has a standard wherein, say for example, 2 degree per minute is what it will be set value in the smoke detector. So when the temperature increases for 3 degree per minute, then there will be a notification and it will be sent to control alarm and it will be a alarm signal initiated. So if you see the smoke detector here, this is how it looks. So well, smoke detectors works into a 24-volt DC. So you'll have a positive connected here, a negative connected here, and you'll have the earth wires connected here. It's the same for all the devices, smoke, heat, or any fire alarm device. There you'll have a positive, negative, and earth. So all these has to be wired properly without any open and short circuits. Okay. So going forward, so there are two type of smoke detectors. We saw two type of heat detectors previously. Now we are seeing two type of smoke detectors. So there are two type of smoke detectors, which is photoelectric smoke detector, and the next one is an ionization smoke detectors. Basically, both are detectors which senses smoke. Just the operation principle of these detectors are different. Okay, so the photoelectric has a okay, the ionization is more of an old technology which has not been followed now, and it's expensive comparatively compared to photoelectric. So photoelectric is something like the smoke hits the photoelectric sensors inside the smoke detector, and the alarm is being issued given to the fire control panel. Ionization detectors is the same. You have two conductors inside where the conductor is being broken by the smoke, and you are getting a smoke. So this is an arrangement of what you see inside a smoke in an ionization detector. This is how it is. Okay, too complicated compared to what you see in photoelectric detectors. The next type of detector what we are going to see here is the duct detector. So this is how it is. So well, to be more clear on it, this is the smoke detector which you are seeing here. The smoke detector is the duct detector is nothing but a smoke detector installed with a sampling tube. Why we have a sampling tube is the sampling tube will be punched inside a duct. So okay, now going one step back, I'll ask you what is a duct. Duct is something which supplies airflow to the areas. So have given a small pictogram of how it works. Okay, now we will. This is how the air comes in for a HVAC equipment. Wherever you have ACs in a shopping malls, you would have seen diffusers. So this is what the diffuser which flow gives you the airflow, and this is a fan, and this you see the S here. This is a smoke detector. So this will have a punch-in sampling tube here. So when the when the air comes from here, in case it has a addition of smoke to it, this will sense, okay, and it will give a signal to the control room. Similarly, you will have another. This is a supply duct. If you can see the direction, right? So this is the supply duct. And if you come here, it's all the way other way around. It's a return duct. So from here it is going outside. So you see the fan directions. This is how it is. So when the smoke detector is installed this side, so if there is a fire either inside this area or from somewhere supplied here, so you will have a smoke detection indicated, and this will give a information to the uh, to the main control panel again. Now we have one more detector called flame. So it's from the name itself. It says flame detectors. These are detectors which is installed in areas like oil and gas areas, wherein the type of flames are identified. So there are many type of flames. Like you would have seen in simple words, red, blue, and yellow type of flames. So the each type of flame has a different characteristics. In case the characteristics is deviated, these flame detectors helps you to identify, and there will be a notification issued to the control room again. Now we'll see how we place these fire detectors. Okay, so fire detectors has to the smoke detectors or fire detectors or duct detectors has to be placed evenly in reference to construction standards. Basically, we have to follow the manufacturer's recommendations as well. A detector can cover an area of around 5 square meters. Okay, so you have to place the detectors in such a way, and you have to take into consideration the installation of detectors also depends on the maintenance factors. So you have to maintain a smoke detector even after installation. So this has to be taken into consideration. Now beam detectors. This is another type of detector, and this has to be installed in areas where we cannot install a smoke detector, or the coverage of smoke detectors or detectors are will not help you, such that if you see here, the the smoke detectors. Sorry, this is how the beam detector looks like. So this is a transmitter. This is a receiver. So the transmitter will be wired up to the fire alarm system control panel. Okay. So this is a transmit. This is a transmitter. This is a receiver. So from the transmitter, there will be IR rays always being given to the receiver. So receiver normally it will be a mirror basically. So it has to take the signal and give it back to the transmitter. So it's like give and take. The red line goes all the way to the transmitter and gives back the blue line. That's how it is. So if you see here, I have shown you a small presentation of how what is the height of this 11 meters. So when you are installing a smoke at 11 meter, the problem will be the coverage will be less. You have to add multiple smoke detectors there. To avoid that, we can use a beam detector. Okay. So, again, slide should have been earlier. Anyway, this is how it is. The placement of the fire detectors is like this. So you have to install it like 12 inch below the ceiling. The reason for installing it 12 inch below the ceiling is when a smoke goes all the way from the floor, it stays on the ceiling. Yes, but the smoke will not stay. It's not stable. It will be moving around, and it bounces in and out. They have it installed at 12 inch below the ceiling. And the next point is, so it is advisable to have the smoke detectors all around the building. Okay. So I'll show you a small pictogram on how and where all we can install these smoke detectors. Now, this is a plan of the same house. So when you see here, this is a hallway. So it's better to have a smoke detector in this area. So if it's a kitchen, in this kitchen we have to install a heat detector. Dining, we can install a smoke detector. Bedroom, it's advisable to have smoke detectors. Bathroom, preferably not to install anything because it is bound to water. But again, there are devices which are suitable for bathroom setups as well. It depends on the client's funding for the project. Master bedroom, again, you will prefer to have a smoke detector. Okay. Now we'll see how and where we install these detectors. Okay, it's like this. Now we have a conical area like this, and where do we install the smoke detector? If you can install it here, but these spaces will be vacant. If smoke comes and hits here, you will not be able to identify here. But 1 meter below the ceiling level, so that when the smoke is distributed, the smoke detector will be able to identify the smoke. Now we are going into, so we have almost seen all the input devices. Now we are going to, no, we have one more input device. I'll finish it and come back to the notification. So this is the last input device. So interface modules is one of the input device. So we have two subdivisions in interface modules as well. So one is a monitor module, the another one is a control module. So what is a monitor module? So if there is, we will have zone control switches, pressure switches, and there will be systems which are being monitored by the fire alarm systems. So these systems will be connected to the fire alarm through a monitor module. So when you monitor it, like what is this pressure switch, how it works and all, we will see the second session when my colleague comes in. So these systems will be monitored by the monitor modules and control modules. So you are identified fire in a facility. No, when you identify stand for this temperature. So we have to go for FP200 cables, which is fireproof 200 cables. So it depends on the project again. And we can use MICC cables also. MICC is mineral insulated copper conductors. So these cables are preferably used for fire alarm systems. Now we can follow two fire alarm system, which is class A and class B. Again, this also depends on purely on the project specifications, requirements, and all. So how we connect it and where is what is just in a simple drawing I've shown here. So if you see here, so this is a smoke detector or whatever device we call, like the strobe, speaker, whatever it can be. From the control panel, we are giving a positive wire and a negative wire. So it is going to the device, coming out of the device, it is getting back to the panel. This is a class A wiring, and you will have multiple devices in it. I've just shown one device here. Okay, and this is a class B wiring. So what is a class B wiring? We'll go to the device and we'll close it with the end of line resistor. Why we put an end of line resistor? Otherwise it will show a open circuit, or it will show a return voltage. So either of it will show. So to avoid it, we'll close it with the end of line resistor. Now we have done all the installation based on standards. We have followed everything. We have installed the device, strobes, speakers, and all those things. How do we document it? How do we know that where this is installed and all? So to finish a project, you should have all these documents listed out so that anybody who is maintaining have all this information. In some system narrative, like it will show, system narrative will show a description of the project. Like you have a fire alarm panels, you have repeater panels, you have like the mimic panels here and there, you have number of smoke detectors, you have number of devices. You should have major floor plans and how many equipments we have connected to this, and the design specification on what basis the standards being followed. Again, we'll have two more important documents, like it's called a riser diagram or schematics, and a sequence of operation matrix. I'll show you a small couple of slides showing what is a riser diagram and what is a sequence of matrix. This is how a fire alarm single line diagram looks like. So this is a main fire alarm control panel, and from the control panel you will have devices connected in multiple loops. You have like you will have same zone separations 1, 2, 3, 4, and you will have devices connected. And most important thing is the initiation devices and the what do you call, the secondary devices has to be in separate loops. There are technology now being introduced that you can have the input and output devices on the same loop. Again, it's up to the client to decide if they have to use it or they will not use it. Okay, so this is schematics, and we'll go to the next slide. This is how the sequence of operation looks like. So what is a sequence of operation? If you see in the left side tab, you have system inputs. These are the input devices. So you'll have the detectors listed out here, detectors, and whatever the input devices you have, you will be listing out here based on zone and zone separations. Okay, it might be floor, it might be zone, it might be area, whatever. And you will have all the output devices here. So you will have the lift, you'll have the access control systems, the pumps, the generators, and all those things based on, and the notification devices, very important. The notification devices will be in here. So it's like this. Say you have a smoke detector being identified. So where does the signal go? The first dot shows that it goes to the fire alarm panel. Okay. The second dot, if you see, it's to the next output device. But we will be giving input to the notification devices when there is a fire. This is how it works. Again, this is purely based on rated. Like you have in case you have a 15 floor building, and you cannot have all the floors evacuated all of a sudden because there is a fire in the 10th floor. So obviously you have to do it zone wise, because your occupancy, or say the 15th floor is having 1500 people or a couple of elevators. You cannot escape. You will have to separate it zone wise. So first 3 floors